welcome to lecture 7 of Python. So, and this lecture, the topic of this lecture will be sorting. So, we'll get into the introduction of sorting in this lecture. So, before we move into it, let's look at last week's homework. And in case you have questions at any time, feel free to ask them in 5 questions. I'll be happy to answer them. Cool. So let's look back at last week's homework. So the first homework was to get as an input a, b, c, which are the coefficients of the equation ax squared plus bx plus c, which is a quadratic equation. And you had to solve them using the formula x is equal to minus b plus or minus root b squared minus 4ac by 2a. So, and you had to use the math module, which was taught in the previous lecture. So that was your first task of last week's lecture. So let's look into how we would do that. So since we're using the math module, the first thing that you would do is import the math module. So you would use import math, and next you are required to get as an input a, b, and c. So that would be our following commands. So you will be required to enter a, b, and c. Now once that is done, since this is a big equation, what I would like to do to keep it much more readable is first calculate the root b squared minus 4ac, then calculate the rest of the equation, because as a whole this is a pretty big equation to write it. It'll look a bit more complicated, so it's better to shorten it so that it's much more readable. So that's what I would like to do in this case, but it's still a personal preference. You could do it however you want. So the first thing I would do is like to calculate the b squared minus 4ac first. So that is called the determinant in this case. So first thing, we start usually the way you calculate is move from the outside to the inside. So b squared minus 4ac is inside a root, a square root in this case. So the command for square root is math dot square root, or sqrt in short. And the next thing is b squared. So you could use this, but since you're required to use the math module, you could it's math dot pow for the power. And since you're squaring b, you put b and comma 2. So this squares b to the power of 2. Sorry, it squares b. And next what you do is you subtract it to 4ac. So it's 4 multiplied by a multiplied by c. So this basically is square root of b square minus 4ac. That's the determinant here. So it's a plus or minus sign here. So since you have equations where certain things have two roots, certain you have imaginary, and certain things you have just one root, but the formula states that you must have two roots, which is a plus sign and a minus sign. So what we would do is I would like to call it root 1 and root 2. So root 1 would basically be with the plus sign, and root 2 will be with the minus sign. So it would be minus 1 multiplied by b, and the first thing I'm going to do is add it to the determinant. Let's see. And this whole thing will be divided by 2a. That's the first one. The second root would be the same thing, except instead of a plus here, it would be a minus sign. So I would do it this way. So this would result in the two roots, and the next thing would be to print both of the roots. Say the roots are and root 1 and cool. So let's try it now. Let's try it with the equation ax square, so which is x square plus 6x plus 9. So that would give us minus 3 and minus 3. It's the same root because this is basically the expansion of x plus 3 whole square, which would give us x square plus 6x plus 9. So since it's you get two similar roots, you could modify the program to say, if the roots are equal, just print one, and if the root happens to be imaginary, then say the roots are imaginary, and if the roots happen to be two different, then you can do that. But since we just wanted to use the math module in a program, that's what the homework was intended to. I think this should do. But you could modify the program to say that the root is -3 because there's just one root, both are similar. So you could modify it to that, but still uh, I think that should do for the homework. Cool. So let's move on to the second one. Since the second one covers the topic of today's lecture, we look at the third one first, then move back to the second question. So the third question was to get a string of numbers from the user, and you had to print the odd and even numbers in descending order as a string using a while loop. So there's quite a lot of steps to it. So let's break it down how we're gonna go about it. So first things first, we had to get a string of numbers from the user. That's the first thing that you're required to do. So we'll just say enter string of numbers. Cool. Now that's done. So the second thing is asked to you have to print the odd and even numbers in descending order as a string using a while loop. So what I would do is first I'll get the string, and the first thing that I would probably do is split them into odd and even. So let's say I have an odd list and an even list. So the odd list would have the list of odd numbers, and the even list would have the list of even numbers. So first thing that I would do is separate both of them, then I can arrange them in whatever order that I want to. So since I have to use a while loop, I have to declare a variable to 0, because a while loop you have to declare a variable to loop to, and I'm declaring it to be I is equal to 0. So we're going to loop through the entire length of the string. So I'm giving less than length of a. So after that, what we're going to do is simple condition to check whether the number is even or odd. So all you have to do is to check whether the so-called number is divisible by 2. So this would be the normal condition that we would type. But since it's a string, so for example the string would be like this, we want to check each number. So what we would probably do is a of I, since I is 0, would give us 1, but still 1 is a string. So if I try to divide a string by 2, it's going to give an error saying that string can't be divisible by 2 because it's a string. So I would change it to int here temporarily so that we can compare and check whether it's equal to 0. And if it's divisible by 2, we're just going to append it to even, and if not, we're just going to append it to odd. So it's basically a simple check to check whether the number is even or odd. So a of I would be, if I is 0, a of 0 would be 1 here in this case, the first character in the string. And since string can't be divisible by 2, we are converting it to an integer to check whether it's divisible by 2 and append it based on the condition. So another thing that you have to remember in a while loop, you have to increment the variable yourself, because a while loop doesn't do that. So once that is done, we would probably get a string of odd numbers and even numbers here. So let's just check whether that worked. Let's just print the odd. So let's say a few numbers. Cool. So we have the odd numbers here and the even numbers separately. So we did that. So the second part of the question, or I should say the third part, was to arrange them in descending order. So I didn't want you to do them yourself. I said that you could use the sort method. So if the list has a function called the sort function. This arranges them in ascending order. And the list also has a function called the reverse. So basically reversing an ascending order would give us the descending order of things. So all you need to do is the same thing for even. And so now if we try and print the strings, they should be in the proper order that we want them to. Let's try to see. So you can see it's in just a minute. Yep. You can see that it's in descending order. The lists are in descending order right now. So okay, but the question also demands you to do something else, which is to convert the list into a string. As of now, this is a list. So since instead of printing 8420 in list, what we would essentially want to print is this, and not in the form of a list. So you were asked to convert a list into a string. So in the homework, I gave a hint, and the hint was to use the join function. So that would essentially convert the lists into a string. So that's what we will be doing. So basically what the join function does is, in this case, if I give dot join and I give odd. So to illustrate the syntax of the join function basically, it takes in a string here, and then you type in join, and you probably give a list inside. So what happens is, if the list happens to have numbers like this, and if the string I give is example hi, this list would essentially be converted into a string which basically says 1 high, 2 high, and 3 high. That would probably be it. I think just stop. So doing that here would result in all these getting converted into a string of numbers. Let's just say. I'm sorry. Here. Cool. So you can see that it's been converted into a string, and the odd and even numbers are in descending order as well. So the point is, if I happen to give any other string here, let's say hi, and I type in a few numbers, you can see that each of the string gets separated by the string given here. So what it actually does is, first we notice that the odd number contained lists. So what happens, each number in the list, so the first number is added. After it, whatever is given inside the string gets appended after the first element. Then the second element is added. Following the second element is the string, and it goes on forever. So it's basically the first element in the list, the element followed by the string, followed by the element, followed by the string. So that's how it goes. So that's how the join function works. So in this case, we'll just give an empty string here, because we don't want them to have any string or any of that sort in between. I'm sorry. So it will just join them without any spaces. If I happen to give a space, then probably all these strings would have spaces between them. Sure. It's a bit slow. Cool. You can see that all the strings have spaces between them. So that's for the second or the third question of the homework, I should say. So let's move back to the second question, because that's the topic of today's lecture, which is sorting. So this was your second homework for last week's lecture. So okay, you had to get a list of numbers as an input from the user, and you had to use for loops to sort them in ascending and descending order. So let's go through how to do it. The first thing demands you to get a list of numbers as an input from the user. So we just use the eval function to get a list of numbers. Enter list of numbers. So that's the first thing that you have to do. Okay. So once that's done, you are asked to use a for loop to sort them in ascending and descending order. Okay. So I'll write the code, and I'll walk you through how the code functions. I'll also give you a pictorial representation of what this is. So basically what we're doing is we're sorting these numbers. That's the term we would use to sort of thing. So we're sorting these numbers in a certain order. So Python has a different, you have different types of sorting algorithms, and the one we're going to see first is called the bubble sort. So I'll type in to show you how it works first, or we'll go with the pictorial representation first. Okay, so this how the bubble sort works. So it's a pictorial representation to show you guys how it works properly. So let's say I have this list of numbers here. It's 5, 1, 4 to 8, and I want to sort them in ascending order. You can see at the end it's sorted in ascending order. So how the bubble sort functions is it first checks whether the first number and the second number. It first checks these two numbers. It checks whether the first number happens to be less than the second number, and in this case the second number happens to be less than the first number. So in this case, the second number here happens to be less than the first number, and since we want it in ascending order, we're just going to swap them. So one goes into 5's place and 5 goes into 1's place. Now that's done. So what happens is next it moves on to the third number. It checks whether the third number is less than the second number or the previous number, and in this case it happens to be less. So again it's swapped. And again in the third case it checks whether the fourth number is less than the third number, and it's true in this case, so it's again swapped. And finally it checks whether the last number is less than the previous number. In this case 8 is not less than 5, so it remains as such. So once this is done, what happens is there's a second check which happens. So in this case what happens is it doesn't check from the first, it starts from the next one. So it does the same thing. It checks whether the next number is lesser than the previous number, and it goes on swapping till all the elements are in proper order and you get the final result. So this is to have a small pictorial representation of how the bubble sort works. So let's move into the actual code. I'll be doing a few problems based on bubble sort so that you get the hang of it. So the first thing that you do is you would want to go through each element in the list here. So we're just going to go through the whole list. So we're using length of A to traverse through the whole list. So this is where the algorithm kicks in. So you need a second loop. It says for j in range 0, len of A, I, 1. I'll explain it to you how it works, what this for loop actually means. But for the next part, it's pretty self-explanatory, as I explained to you before. We're checking whether j is greater than A of j plus 1 in this case. So instead of checking, the second number is less than the first number, we're just checking whether the first number is greater than the second number. It's the same thing. So if the first number happens to be greater than the second number, we're just going to swap them. So a simple command or a simple way to swap them is just have these two and assign it to the opposite. So this is how you would swap in Python. Python makes it much more easier. So this is basically saying I have the variables A and B, and I would want A to store the value of B and B to store the value of A. So once this command is executed, A will have the value of B and B will have the value of A. So that is basically the swapping thing that we're doing here. So once that's done, we're just going to print A and see how it works. Okay, let's give it a list of numbers. And let's see what happens. Okay, so as you can see, it gets printed in ascending order. Okay, let's go through the code. So the first loop basically traverses through the whole list. So length of A in this case would be 6. So I would start from so i's value would start from 0 and it would move to 5 because the length of A is 6, and for I in range only moves to this value -1, so the stop value -1. So I would take the values from 0 to 5, and we have a next loop which has a pretty a unique range, which happens to be length of A minus I minus 1. So length of A is a fixed value, which we know here in this case is 6. So 6 minus I is a variable, so which keeps on varying each time the loop goes, -1. So we could just equate it to say 5 minus 1 in this case, 5 minus I in this case. Cool. So let's see how it works. So at the first time I takes the value of 0 and j would probably be 5 minus I is the range, so it would be 5 minus 0 in this case, which is 5. So j will also start from 0. So the first thing what it does is, let me just give a sample list here so that you guys know. Okay. One more thing to note: the length of a minus I minus 1 is a standard thing to use using bubble sort. I'll explain you why this command is used so that you understand why we're using length of a minus I minus 1. Okay, we have the list here, and I takes the value of 0, j takes the value of 0 as well. So the first thing that we do is we check a of j is greater than a of j plus 1. So we're basically checking whether 2 is greater than 4 in this case. So in this case, 2 doesn't happen to be greater than 4. So this swapping doesn't happen. Okay, moving on. J takes the value of 1. So this time we're just going to check whether 4 is greater than 5, which is also not true. So next j would take the value of 2. And this is where we check whether 5 is greater than 1. And in this case, it is true. 5 happens to be greater than 1. So basically what happens is the list becomes 2 comma 4 comma you know what I'm going to do, I'll probably print the list for you guys so it's much more easier for you guys to visualize what happens. Okay, so if you notice here we have the list here. So the first thing that happens is it checks whether 15 is 1 is greater than 15, which is not true. The next thing what happens is checks whether 15 is greater than 7, which in this case is true. So they get swapped. So that's what's happens here. So I'll print this as well. So it checks whether the first thing that checks is whether 1 is greater than 17, and in this case it is not true. The next thing that it does is it checks whether 17 is greater than 0. So since 17 is greater than 0, you can see 0 and 17 have been swapped. So the next thing that it happens is now after 17 and 0 has been checked, the next thing what happens is checks whether 17 is greater than 13, which is also true. So 13 and 17 also get swapped. And next what happens, it checks whether 17 is greater than 2 in 2, and in this case also it's true, so 2 and 17 get swapped. So once this iteration is done, we move and next it starts checking from these values here. So what happens is it then checks whether 1 is greater than 13, which is not true. Then it checks whether 13 is greater than 2, which is true, and so 2 and 13 get swapped. So after that, finally it checks whether 13 is greater than 17, which is not true, and we end up with this. So basically what this length of a minus I minus 1 does is, when you have the value of I to be 0, length of a minus I minus 1, in this case since we have the list to be of length 5, would give you 4 minus 0, which is 0. When I happens to be 1, this command would result in 4 minus 1, which is which would result in 3. And when I is 2, it would result in 2, and when I is 3, it would result in 1. And finally, when I takes the value of 4, j will result in the value of 0. So basically what we're doing is we're starting by checking from the first element, and this starting by checking in the first element. So once we start checking by the first element and run through the whole process, we then start by checking from the second element, because already we started checking from the first element, so we need not have to start checking from the first element again. So that's where this command goes. So when this happens to be 4, j can take the value of 0, 1, 2, and 3, and in this case j is restricted taking the value of 0, 1, and 2, and it goes on forever. So what we're basically optimizing the program so that it doesn't keep on running, and we're just going to keep it short by checking these two and these two. So the pictorial representation here says the same thing. So basically the initial intuition of this program is it checks whether a previous number is greater than or lesser than the following number, and if a certain condition matches, we just swap in. So the len of a minus I minus 1 is a standard condition that you use in bubble sort. So this is probably, you could say, a syntax of bubble sort. This is probably the command that you would use when you're using bubble sort. So this is for ascending order. So let's see how you would do it with descending order. It's just a simple change in the program. So in this program, you're checking whether the previous number is greater than the following number. So if we just switch the command to the opposite sign here, now if we enter the same numbers, which happens to be 1, 17, 0, 2, you can see it gets now it's in descending order. So a simple change, what happens here is, I'll just print A to show you guys what happens. Okay, so the change is basically, we check now whether this number is lesser than the following number. So that's what we're trying to check. If it's less, we're going to swap. So 17 is not less than 1, so we're not swapping. As the loop goes on, we check whether we find that 0 is less than 13, so we swap them, and we also find that 0 is less than 2, so we swap them, and we move back, we check that 1 is less than 13, so we swap them, and we also check 1 is less than we find that 1 is less than 2, so we swap them, and at the end the loop happens to be in descending order. So we keep on checking whether the previous number is less than the preceding number, and then we swap. So it's just a simple change in sign which changes the whole program into an ascending order to a descending order. So let's solve another program for you so that you guys are familiar with it. So let's say I want to write a program to sort a list in alphabetical order based on their first letters. Let's just take their first letters and sort them. So if you've listened to our previous lectures, you know that each character has a set of Unicode value. So A has a set of Unicode value, the bigger A has uppercase A has a set of Unicode value, and B. So all we need to check is whether A is greater than B or A is less than B. So A's Unicode value will obviously be less than B's Unicode value. So we just need to check whether this is true, and we can swap them. So the first thing that we would do is we would get a string or a list of strings in this case. So we're just going to get ask the user to input a list, and we're going to do the same thing. We're going to traverse through the whole list. So length of A, and the next thing we're going to do is a standard condition in bubble sort, which is for j in range 0 comma length of A minus I minus 1. And this is where the condition kicks in. So let's just say I enter a list like this. I enter let's say box, apple, and elephant. So what we need to do is we just need to check whether the first letter is greater or lesser than the second letter. That's what we need to check here. So A of j would give us, if j happens to be 0, A of j and would give us box, but we don't want to check whether box is greater than or less than apple. We want to check whether B is less than or greater than A. So we would use another parameter here, which is giving 0. So to show you why this is done, A is the list as a whole, and A of 0 in this case would give us box, and a of 0 would give us the first letter in box, which is just b. This is what the command here does. And since we just want to check based on their first letters, we just use default 0 here because the index 0 corresponds to the first character of the string. So that's why we're doing this. And since we need to sort them in alphabetical order, we need to check whether if a happens to be greater than b, sorry. So the condition here would be is we will check whether the previous number or the previous letter happens to be greater than the following letter, and if so, we're just going to swap them. Same condition here, we're just swapping variables. So to show you what this does is when j happens to be 0, so when j happens to be 0, a of j of 0 would probably be b, since we saw that, so this would be b, and a of j plus 1 of 0 would be a, because the second string happens to be apple and the first character of the string happens to be a, so this would be a and this would be b. So what we're doing is we're checking whether this is greater than this. We're checking whether b is greater than a, and if so, we're swapping them. And since the Unicode value of a is less than b, and which happens to be less than c, and it goes on to all alphabets. So when b happens to be or greater than a, we're just going to switch them because a has to come first, then b. We want to sort them in alphabetical order. So that's why we're checking this condition whether it's true or not. So once we try printing, let's see if it works. So I'm just going to print the list at the end to, oh my god. So let's enter this list here, and you can see it gets sorted in alphabetical order based on their first letters. But there is one problem with this program. The problem is, since we're only checking based on their first letters, we're going to mess. So I'll see why this program is wrong. So let's say that I enter a string AE, they enter another string which happens to be AA, and another string which happens to be A. Based on the dictionary, you would probably find A to be first, followed by AA, followed by AE would be probably the dictionary or the alphabetical order that you would find it in a dictionary. But you can see that this program does not take that into account. The reason, because we're only checking the first letter of the string, which happens to be A. So when this code is run, it's just going to check whether A is greater than A, which is not true, so it's not going to swap. Next is going to check whether this A is greater than this A, it's not true, so it's not going to swap. So all these is going to remain in the same order. It's not checking whether the second letter is also greater than the previous letter. So a simple modification to this program would be to remove this condition here. So we're just going to basically remove the condition of us checking the first letters. So what happens now is when j happens to take the value of 0, a of j is basically AE in this case, if we consider this to be the list, and a of j plus 1 happens to be AA in this case. So Python has this unique way of comparing strings automatically. So when we automatically compare whether AE is greater than AA, what Python does is it checks the Unicode value of the whole string. So what happens is AE, this has an E here and this has an A here. So since when it automatically checks, it finds that AE happens to be greater than AA because both of these are the first letters of the alphabet. E comes after A. So what happens is we just the places of AE and AA get swapped. So now when we try to run this code here, and let's just give the same input. Since now the whole program checks the now it gets sorted in the proper alphabetical order in this case. Since we're not checking by the first letter, we're checking as a whole string whether the whole string is greater than or less than the preceding string. So in this case, it sorts the whole list in alphabetical order, or in the order of how you would see it in a dictionary. Okay, so since this is a new concept to you, I'll give you a task to solve. So your task is to write a program to sort a list of tuple elements in descending order of points using bubble sort. So you're just going to use the same sorting algorithm here. So a list of tuples would be, I want the input type to be of this form. So the input type should be in the form like this. So I need you guys to enter a tuple which is player number followed by player name followed by points, and this would have another tuple inside which would have the same thing. So to give you guys a sample output of this program, so I would probably want your input to be like this: a string, a list of tuples inside a list. So I want you to sort them in the descending order of points. So points happen to be the second element in this tuple. So based on the points, I want you to sort them in descending order. So you can see that they're sorted in the descending order of points here. So the input type should be a list containing different tuples inside, and I want you to sort them in descending order based on their points. So the input type should be player number, player name, and the number of points. So and I want you to use bubble sort. So I'll give you guys like a few minutes to solve this, and we'll walk you through the solution of this task. Okay, I think that should be enough time for you guys to solve the previous task. Okay, let's see how we can solve it. Cool. So the first thing that you require to do is to get as an input a list of tuple elements. So simple command, we would use the eval function to get in enter a list of tuple elements. And the next thing we would do is we would traverse through the whole list. So we have the outer loop which is for I in range len of a. Then we would have the inner loop which follows the bubble sort algorithm, which is 0 comma len of a minus I minus 1. And then comes the condition that we want to do. So since it's descending order, which means that the highest point should be at the beginning and the lowest point should be at the end, the way we would swap is we would check whether this happens to be greater than this. If in any case, or let's take an example, 2008-13 happens to be greater than 2007-110. If that is the case, we want to swap 2008-13 in the place of 2710 and 2710 in the place of 2008-13. So that will be the condition. So we're basically checking whether the previous element is less than the preceding the element that comes after it. Okay, so how do we access the point here which is inside a tuple which happens to be inside a list? So it's quite a few things that we need to go into. The first thing that we do is we type in the list name, and a of j would give us the tuple. So if j happens to be 0, we would get the whole tuple here. But we want to access the points part of the tuple, which is element 2, because element of index 0 is 10, which is the player number. Element of index 1 is the player name, and element of index 2 is the points. So to access the point, we would say a of j of 2. A of j would give the tuple, and 2 would give the points part of the tuple. And we would check whether this is less than the tuple that comes after this. In this case, if this is less than this, we're just going to swap them. So then comes the swapping condition. Just gonna do this. Yeah, and once we print this, it should. Okay, let me just copy this here. Yep, that returns the list of tuple elements in a descending order of points. Cool. So that's it for bubble sort. So we have another type of sort called the insertion sort. So what we saw previously was called bubble sort, and this is called the. We're going to look at something called the insertion sort. So to give you an intuition behind insertion sort, let's say that you've been given a lot of answer sheets of a certain exam, and all these answer sheets have like roll numbers which start from 100 to say till 110. So the answer sheets has been given to you in the order of roll numbers has been jumbled. So I have the roll number 103, like 107 here, 102 here, 100 here, and so on. And you're asked to sort them in the order of roll numbers, which starts from 100 to 101. So I mean till 110. So what you would probably do is you would take the first two sheets, which is 103 and 107, and you would put 103 on top of 107. And then you would probably take 102 here. And since 102 happens to come before 103, you would push this down, like let's say I draw a line here. So I push this down once, and I put the answer sheet with 102 on top. Then I get the answer sheet of 100, and 100 happens to be the first. So I push all this down further, and I put 100 on top of all the other answer sheets, and I get 101 here. So 101 happens to come after 100 and before 102. So I would push the sheets after 102 one below, and I insert it right here. And this would result in them being arranged in the order of roll numbers. So what I'm doing is I'm basically pushing it down and I'm inserting it. So to show you a pictorial representation of how this is done, let's look at this picture here. So I have a list of numbers here, which is jumbled up, and I want to arrange them in ascending order in this case. So the first thing that I do is I check 12 and 85. So what happens is 12 happens to come before 85. So I push 85 back. I take 12 and I insert it in the place of 85. It's not essentially swapping in this case. I'll tell you why it's not swapping, because we're not. What we did here is we didn't swap an element here. What we're doing is we're pushing it back and we're putting the element before it. So this can be in between any elements, or before, or the first or the last. So next we do is 59 happens to be less than 85. So we push 85 back and we insert 59 in between 12 and 85. And we do the same thing and it follows over and we get the final list here. I'll go through the code so you guys are familiar with how the insertion sort works. So let's have a same program to sort a list of numbers using insertion sort. So first thing I would do is I would get in an input as a list. So the syntax for or the algorithm for an insertion sort works a bit differently and is a bit more complex than the bubble sort. But you would see later on that the insertion sort is a much more efficient way than the bubble sort. It's a much more efficient sorting method than the bubble sort. It's much faster. So I'll just type in the commands here. I'll walk you through how this is done. Copy this here. Okay, so let's just try sorting numbers. Okay, they get sorted in ascending order. So let's just see how this works. The first thing that I do is I go from I in range 1 to the length of the list. I'm not starting from 0, I'm starting from 1, which means 0 happens to take the value of 17, 1 is 82. So I don't start from 17, I start from 82 here. So then what happens is I have something called the key. So what happens is in this case, key takes the value of takes the value of 82, since key takes the value of a of I and I happens to be 1 in this case. And we're using a for loop and a while loop in synchronization here. So I'm declaring j to be a variable which happens to be always 1 less than I. So 1 less than I would give us 0 in this case. So this is a loop which has a condition which says while j is greater than or equal to 0 and as j is greater than or equal to 0 and when the key, in this case 82, is less than a of j, what we're going to do is we're assigning a of j plus 1 to be a of j, and we are decrementing j in this case. We're not incrementing, we're just reducing j of a of j by minus 1. So what this does is, let's just take j to be 0. This condition is true, and a of j in this case is a of 0. A of 0 is 17. So the while loop checks whether 82 is less than 17, which is not true. So this whole condition is not true, since we need both of these conditions to be true for the while loop to execute. In this case, this is not true, so this while loop isn't going to execute. So what happens, we move to the else block here. So what the else block does is, the else block assigns a of j plus 1 to the key. So j is 0, j plus 1 happens to be 1, so it's basically assigning 82 to 82 itself, because a of 1 is 82, so it's just assigning 82 to 82. So it doesn't make sense now. Let's maybe try what happens in the second iteration. So next iteration, I takes the value of 2, so key would become 0 in this case. So I of 2 is 0 in this case, so key is 0. So now when key is 0, j is I minus 1, so j becomes 1. So the same condition here, while j is greater than or equal to 0, and now it's not 82 less than 17 because the key has changed to 0, and a of j now is a of 1, which is 82. So since this condition is true, what happens is a of j plus 1, which happens to be a of 2, and a of 2 happens to be 0, so this gets assigned to a of j, which now holds the value of 82. So 0 gets assigned the value of 82 now. Next what happens is j is equal to j plus 1, so now j becomes 0. So when j becomes 0, we check back again. So I'll just print the loops in between so that you guys understand what's going on. So I'll print the loop right here. And I'll give certain lists as an input. Okay. So what happens here is 17 gets duplicated. So what we do is we check whether this happens to be 0 is less than 17 in this case. So what happens is 17 gets put in the place of 0. So 17 is duplicated twice. After it's duplicated, what happens is 0 is inserted in the place of 17. So it becomes 0 and 17. But while that is happening, 17 happens to be also less than 13 here. So in the place, 3 in this case. So 17 gets duplicated in the place of 3, and here 3 is inserted. So but 17 also happens to be less than 2, so 17 gets put in the place of 2 here. So 17 is again duplicated twice, and so 17 gets duplicated twice. But this is an interesting thing that happened here. The thing is, 2 happens to be less than 3. So that's why instead of inserting 2 here, if we insert 3, because inserting 2 here wouldn't make sense because 2 is actually less than 3. So that's why 3 is duplicated to give space for 2 to get inserted here. So the duplication is essentially what's shown as a space here, because since we can't have spaces in lists, we're just duplicating the thing another time. So when this happens, what happens is 85 is present here in this space, 85 is also present here. But what next happens is 12 gets put in the place of 85, thereby making 12, 85. So instead of these places, all we have is 85 duplicated twice. So in this case, we would have 85 here again, and 59 would be placed in the place of 85. So maybe I'll illustrate with a different list in this case. So let's try just like this. Let's see what happens. Okay. So as you can see, 2 happens to be less than 50. So which means in a descending order, 2 should always come before 50. So hence we switch 50 to the place of 2. So now 50 is duplicated, and next what happens is checks whether 50 is greater than 0 or 0 is less than 50, which is not true. So 50 is again duplicated in the place of 0. While that happens, since 2 is less than 50, 2 gets put here, and this goes on. So there comes a spot where you can see here 2 gets duplicated twice. The reason why 2 gets duplicated twice is we have a 0 here. So what happens is 0 is less than 2, so 2 has to come here, and 0 is less than 50 as well. So since 0 is the least here, we duplicate 2 another time here to accommodate 0 here. So 2 happens to be the index of 0, but the index of 0 should actually be occupied by 0 because 0 has the least value of the whole list. So that's why we're duplicating 2 here so that we can accommodate 0 here. And that's what basically happens in the whole list. If you can see here, 23 has to be accommodated in this space here. So that's why the duplication of 50 takes place, whereas 50 is put in the place of 23, so that later we can remove this 50 and put 23 in the place. And let's take a number like 9 here. So 9 has to come in this spot here. So what we essentially do is we put 50 in the place of 9. So 50 gets duplicated here. So we have two 50s, and we insert 9 in the place of 50, thereby giving us this final list. So basically what it does is it moves the element one step back, and then it inserts the element in between them. So looking at this now, it would seem that both the bubble sort and insertion sort are kind of similar, but they're not similar, and in fact the insertion sort is much more efficient than the bubble sort. So your first homework for this week would involve you looking at and comparing the insertion and bubble sort and checking yourself which is much efficient. So doing that yourself would give you a much better idea of as to why the insertion sort is much more efficient and why this algorithm is in use. So this is a standard for loop and while loop and else block which is used. So at the beginning it seems a lot of code, but as you start to deploy insertion sort in different in various of the programs, you'll get used to it. So let's do one last program. Let's do a similar program that we did for bubble sort, which is to sort a list alphabetically. But in this case, what we're going to do is based on let's do it based on the last letter instead of the first letter. We're just going to sort using the last letter using insertion sort. So same thing as before, we take in an input from the user, a list, and we traverse through the whole list. So we're just going to use the same insertion sort. So one thing that you notice with the sorting algorithms is, irrespective of whatever program that you do based on a sorting, you're going to use most of this code as same as possible. Maybe what you change is the statement here, or maybe what maybe this statement here or something like that. Because let's say that we have the bubble sort here. For three different programs, we use the same structure. The structure always remain the same. The thing that always was different was maybe the less than or greater than sign, and maybe the thing that we checked here. Since we're checking the first letter, we use 0, and since we're checking something else here, we used 2. So the checking part is what differs, but the structure of the sorting algorithm always remains the same. So since we're doing sorting based on the last letter, the structure of the insertion sort is always going to remain the same. So I would first go through the length of the list. I would set a key here, and I would use a variable, then I would deploy the same thing. So I'm just going to copy the structure here because the structure of a sorting algorithm remains the same throughout. So all you're going to do is minor changes, so that what we do is essentially check the last letter of the alphabet. So similar to what we did in a bubble sort, a change that we would do is, since we want to use the last letter, and let's assume that let's just say enter a list that something, it looks like something like this. This is apple, and it was like let's say box here or something like that. So key when I is 0, when I is 1, key basically has box as its value. So how would we access the last letter and check the last letter instead of checking the whole thing? So if I do this, it's going to check the whole thing is less than or greater than the next thing. But since I only want to check the last letter, the simple thing that I would do is use -1. If you attended the previous lecture, you would know that -1 basically refers to the last character of a string or the last element of a list. So this is negative indexing. So using -1 would give x. So in case I use -2, it would give me O, and in case I use -3, it would give me B. -4 would probably return an error because we don't have anything here. So -1 would give me the last character of this string here, and obviously I want to check it to the last character of a string. So all I do is I put in a -1 so that we check the last characters. The rest of the structure of the whole insertion sort remains the same. So let's run this and just type in a few. Let's say box. Cool. So you can see at the end we have all these sorted in the based on the last letters. So A comes first, followed by E, followed by O, followed by X. It's not in alphabetical order, it's sorted alphabetically based on the last letter. So what we did was a simple change in this part of the program, which is to add the negative indexing of -1 so that we check the last letter. So what I would probably recommend that you do is try out the sorting algorithms yourself. First type it out yourself and try modifying bits and pieces of the sorting algorithm to see what happens and how it works. So rather than me explaining why there is a key and why there is a j or j-1, if you try it out yourself and try to experiment with it yourself, try printing the key and check what the key prints each time, or try printing that thing. So a thing that I would do when I'm programming is, if I don't know how a program runs, I would just print what the variable is to check what it is. So in this case, if I don't know what a key takes each time, I would just print key to check what key happens to be each time. So and in this case, I come to know that it happens to take the element of index 1, then 2, and that's it. So in case that you don't know what a program is doing, I would recommend you to print a certain variable which is present, so you know how that variable is modified or what happens to that variable in case you have some error or something. So when we're experimenting with this week's homework, implement the basic insertion sort or the bubble sort algorithm. then try to modify the algorithm so it fits the purpose or fits the task that's been assigned for you based on the homework. So all we did was the structure always remained the same of the sorting algorithms. The thing that modified was only the checking condition here, but the structure always remains the same. So at the first it might look there's a lot of commands for you, but as you start using insertion sort or bubble sort algorithms, you will feel you will feel that it's much more easier, and automatically the structure would get embedded in your brain. It would automatically start programming. I would end the lecture on this note here. So your homework would be simple. You'll be only having two questions. The first one is to check the efficiency of insertion and bubble sort. So you know how insertion and bubble sort differ, and you will get to understand why the insertion sort is much more efficient than the bubble sort. And the second thing is a bit more complex, but it involves insertion sort and you modifying the insertion sort algorithm so that it fits the purpose of the task that's been assigned for you. So that's it for lecture.